A timekeeping system for Mars. When humans start to colonize Mars, one of the first things we need to figure out is how exactly we're going to keep track of time. Both Mars and Earth have similar day length hours and obliquities. However, that being said, there are huge differences that we must take into account. Now, a year on Earth is exactly 1 year. Surprise. And then a year on Mars is actually roughly twice that amount, which is what complicates time. A year on Mars is actually 1.88 Earth years, which is 687 Earth days, or 668.6 sols, which is a Martian day. Now, to divide up the year into months, we could use the orbit of the moons Phobos and Deimos. However, they orbit Mars in a matter of hours, which is too less useful for any proper time computation. However, we could extend this time interval length by measuring when the rotation of Mars and the orbit of a moon lines up at a certain point. Let's pick Phobos. Phobos takes 7.65 Earth hours to orbit Mars. Mars rotates at 24.6166 Earth hours, so that's about 3 revolutions of Phobos in a day. We could model the orbit of Phobos and the rotation of Mars using a sine graph. Now, the blue represents the rotation of Mars and the green represents the orbit of Phobos. Where they line up, and doing the calculations, we get that roughly 9 rotations of Mars sync up with Phobos' orbit. The actual is 9.0101 exchange revolutions. This gives us an astonishingly low discrepancy of 15.04 minutes, which means that every 9.23 Martian weeks, we need a leap day, kind of like the one that happens on February 29th every 4 years. So, to reiterate, 9 sols is a Martian week. Since there are 668.6 sols in a Martian year, that gives us about 74.206 Martian weeks, or 74 weeks, and 1.8 days to spare. Yes, this exactly means that we're going to need to dedicate a 2-day period of rest at the end of the year. However, due to this period of rest, Mars and the Moon won't align until after 4.88 years. So we could account for this by separating years into groups of 9. So, like a decade, except with 9 instead of 10. And we also have to remember that we have a leap day years because of that 15.04 day extra discrepancy. If we divide the year into 74 Martian weeks, and then have 2 days to spare, and then reset the weeks after those 2 days, we see that the orbit of Mars and Phobos will not sync, as they'll be off by a whopping 73.8 degrees. Of course, that means every 5 years or so they will align up, and then 39 years later the moons will align up, but this time exactly at the point sidereally speaking. And then we also have to remember that since we gained 0.2 of a day because we rounded up 1.8 to 2, we should remove a day after 5 Mars calendar years, but then we're supposed to add a day due to the imperfection of a Martian week, so it conveniently cancels. Next becomes the division of the seasons. Now, because Mars has a oval orbit, the seasons are not of equal length. 190 days for spring, 179 days for summer, 143 days for autumn, and 154 days for winter. Now, we could group the Martian weeks into 4 and then have some transition weeks in which the solstices and equinoxes will fall in, of course at varying positions in the Martian week, but the transition week length should account for that. And the setup would look like this. First, you have the transition week for spring, which is when the spring equinox will happen, then plus the 20 Martian week and the 4 days, and that 4 days seeps into the transition week of summer, in which the summer solstice will happen, followed by 19 Martian weeks and 3 days left, which seeps into the autumn days of the transition week, and that gives way to 15 Martian weeks plus 2 days left, and that 2 days is found in the transition week for winter, in which the winter solstice occurs, and then you get the winter season of 16 Martian weeks plus a day to spare, which conveniently brings us back to spring transition week. Now, onto Martian astronomy. Fortunately, Because the Earth and Mars have similar declinations, the skies on Mars are not too different from that of Earth. Your zodiacs are slightly off though, but we can divide them into 24 parts. Here is the sky map for Mars, where blue is the Martian celestial equator and red is the Martian ecliptic. Now, if we see where they intersect, that's our points of equinoxes. And notice they're not exactly in Aries and Libra or Pisces and Virgo. However, they are close enough to be reasonably worked with. So, to summarize, from vernal equinox to summer solstice and back, the constellations are as follows: Orpheus, Sagittarius, Capricornus, Aquarius, Pisces, Aries, Taurus, Gemini, Leo. Now, Virgo is divided into two, first half and second half, and then you get Scorpius. So there's your 12 constellations as per how we see them on Mars. And then we divide each constellation in half. Of course, that means Virgo is divided into 4. So the Sun spends in each constellation about 3 Martian weeks, or 1 Earth sidereal lunar month, which is 27 or 28 days. This means that 24 Martian months fit into the seasons divisions that we created, and with the Martian weeks. The name of these Martian months are the same as the common names of the constellations, plus names like first half and last half to account for the fact that we divided each constellation into 2. So, to summarize, based on the orbit of Phobos and a Martian day, Martian year is divided into 74 weeks with a sol and 0.8 to spare, and a Martian week is 9 sols, and there's 1 extra day we add about every 4.5 years, or 4.88. Each Martian week is grouped into a season, and it's varying in length, and each season has transition period intervals where the solstices and equinoxes will fall in. At the same time, we divide the year into 24 parts, roughly 3 Martian weeks each, maybe varying length like the months of the Gregorian calendar on Earth. Essentially, now we have a lunisolar calendar. So, to conclude this video, let's name these hypothetical 9 sol of each week. First is Sunday, Mercury Day, Venus Day, Earth Day, Mars Day, Jupiter Day, Saturn Day, Uranus Day, Neptune Day. So instead of like Sunday, Monday of Earth, we just use the order of these celestial bodies in the solar system. Interestingly, we have a Uranus Day, Neptune Day, and a Pluto Day. Then there's also a Phobos Day and a Deimos Day to make up our 9. And then every leap day, we have a Martian week of 10, which we'll just call Leap Day. Thank you for watching. Like and subscribe. Please review it.